Hi, Math Enrichment 8. Today we're going to talk about when to use negative exponents with division. Go ahead and take out a piece of paper and just work right along with me. Pause whenever you need to in order to write everything that we do down together. Please start with the title. Put the title at the top of your page. When to use negative exponents with division. Okay, let's get started. Okay, so let's look at a division problem with exponents. Let's look at something like x to the fifth divided by x to the second. Just to remind you about the rule for dividing with exponents, let's do this out the long way. So x to the fifth means we have x used as a base, as a factor there 5 times, and x to the second means we have x used as a factor twice. Well, we can cancel every time we see an x over itself or a number over itself, anytime we get those pairs, and they make 1, and that's why I'm making a vertical 1 here. They're not crossing out and making 0, they're making a 1. So if we take a look at what we've got here, we have x to the 1, 2, 3 third power here, and on the denominator, 1 times 1 just makes 1. So that's just x to the third. Oops. The 3, trust me, there you go. Okay, so this comes out, its final form is not a fraction because anytime you have something over 1, you don't need that over 1 part. So this comes out so it's not a fraction. Let's look instead at another example. Let's look at something like x to the fourth over x to the sixth. And again, let's work that out. So x to the fourth is using x as a factor 4 times on the top, and x to the sixth is using x as a factor 6 times on the bottom, the denominator. Let's cancel out all the pairs that we have. So there's one pair, that's 1. There's another pair, there's 1. Another pair, that's 1. Another pair, that's 1. So we're left with 1 times 1 times 1 times 1 in the numerator. In the denominator, we have x to the second. Okay, so another thing I want you to notice, and just kind of thinking back to our rule about dividing powers with the same base, there's a shortcut to this, and that tells us that we can subtract the exponents. So if we're trying to keep our result with a positive exponent, we look and see, okay, we've got an exponent of 5 here, and an exponent of 2 here. This is the bigger power, 5. So if we take, we're going to have more powers of x left over in the numerator where we have 5 factors of x. So if we do 5 minus 3, that's going to give us our 3 that we have. And again, this lands in the numerator, which means we don't need that over 1 part at all. So we're just subtracting the exponents, and we get 3 as our exponent on the x, and it's all in the numerator. Over here, we look at our exponents, and we see we have more powers of x in the denominator down here. So we know that the leftover powers of x are going to be in the denominator, like you see them here. They're left over right here. So what we're doing is basically saying, okay, we're taking the bigger minus the smaller. 6 minus 4 is going to give me 2. And again, I'm putting that x in the denominator because that's where there were more powers to begin with, so that's where it's left. So it's 1 over x to the second. Okay, so this is the kind of problem when it comes out to a fraction that you can also use a negative exponent on. So let's look at that same problem in a different way. So here, let's change colors back. Let's go to red. Let's erase that. Okay, whoops. All right, so if we have, again, x to the fourth over x to the sixth, and if we want to use a negative exponent instead, that means we don't have to write it as a fraction at all. We just put our x, which is going to be our base, and then we subtract the exponents in order from top to bottom, no matter how they go. So this would be 4 minus 6. Okay, so think about what you know about positive and negative numbers when you combine them. Who's going to win, the positives or the negatives? Right, the negatives. There are more negatives. How much are they going to win by? By 2. So these two answers, x to the negative 2 and 1 over x to the second are the same thing. If you want to write it without using it a fraction, then you can go ahead and just call it x to the negative 2 power. Okay, let's try a couple like number 2. Again, this doesn't apply to number 1 because that wasn't in fraction form to begin with, but any that we can write in fraction form, we could also write instead using a negative exponent. All right, let's try some more. So let's try, let's say y to the second over y to the 7th. So if we were to do this out the long way, or actually let's just use the rule for both. So if we're going to write it with positive exponents, we need to look and see where do we have the bigger power of x. And we've got a 2 here, and we have a 7 here. Okay, so there are more power, of y. Where do we have more powers of y? Sorry, guys. And we have more here in the denominator. So that means our leftover powers of y are going to be down here in the denominator. Okay, so if we take the difference between the two, between the two exponents, a positive difference, we're taking the bigger minus the smaller, it'll be 7 minus 2, which gives us 5. But since it's in the denominator, we need to have a 1 on top, so we get a fraction answer, 1 over y to the 5th. Excuse me. You can also do that same problem if you want to avoid using fractions, like the IXL you're doing from Mrs. Otsuka this week, those of you who have her. Then just use the rule subtract your exponents in order, top to bottom. So you get y to the 2 minus 7 power, which means you're going to have y to the, who's going to win, positives or negatives? Yep, negatives. Y to the negative 5th. And that's why 1 over y to the 5th is the same as y to the negative 5th power. So it just gives you another way of writing it without the fraction there. Let's try, let's do 2 more. Okay, oops. Okay, number 4. Let's do m to the 3rd over m to the 5th. So if we use the rule and want to leave the exponent to be positive, then we need to see, okay, where do we have more powers of m? Is it in the numerator, where the power is 3? Or is it in the denominator, where the power is 5? Okay, obviously it is in the denominator, where the power is 5. That means our leftover powers of m are going to be down here in the denominator. And if we just subtract the bigger number minus the smaller number, 5 minus 3 means there'll be 2 powers left over. And on the top, you're going to need to have a 1. And so that's going to stay just like that in fraction form. And then we can use the rule again if we need to put it in a, if you can't use fraction form, if directions or something tell you not to use a fraction, then we're just going to subtract these in order from top to bottom. So this will be m to the 3 minus 5 power. So what's 3 minus 5? Who's going to win, positives or negatives? The negatives by 2. So do you see how these two mean the same thing? Okay, last one. Let's say we have k to the 4th over k to the 8th. Okay, so where do you have more powers of 4? In the numerator or in the denominator? Okay, this time again, they're in the denominator. So if we are going to look for a fraction form answer, the k is going to be left here in the denominator, and then subtract the exponents in, biggest minus the smallest. It would be 8 minus 4. So that's going to give us k to the 4th in the denominator with a 1 on the top. So that would be in fraction form. If you are being asked to make sure your answer is not in fraction form, then just subtract your exponents in order. So 4 minus 8. You're going top to bottom. So that gives us k to the, is it going to be positive or negative? Negative to the negative 4. So these two are the same. So I hope that helps you understand a little bit about negative exponents and kind of where they're coming from and how they relate to division. So if you strictly follow that rule and subtract them in order top to bottom, you will often get a negative exponent. Remember, it's not going to be every time. It would have to be only times when you had more powers in the denominator than you had in the numerator.